All right, guys. Hey, I am going to teach you guys 8.6, at least part of it here on the iPad ahead of time as a video. Hey, guys, 8.6, this is probably, there's two really big takeaways in Algebra 1 that you need to have. One is, like, how do I graph a line, figure out a slope, that kind of thing, y-intercept, which you spent a lot of the first half of the year on. The second thing, the second big takeaway from Algebra 1 is being able to do this right here. In 8.6, it says solving here. We're not really solving right now. We are factoring. So I'm going to just change this a little bit. We are factoring quadratics. Okay, this is a very important skill. One of the biggest takeaways in Algebra 1, I would say one of the two big takeaways is this lesson right here. So here we go. Let's get right into it. I'm going to kind of cruise through a little bit here, but feel free to pause the video, go back, watch things multiple times. But be sure that you know how to do this. This will come back every single year after this and is super crucial to future math. So just make sure that you're feeling very comfortable doing this. So let's start with this slide right here. We have this quadratic equation. Okay, I know it's quadratic because it has an x squared term. All right. And notice what I did here. I gave you the factored form of this. Okay, so if you factor x squared plus 9x plus 20, you end up with these two pieces. All right, these two things, when you FOIL them out, okay, if you multiply these things out and use your distributive property, okay, and combine like terms, you will get the original back. All right, so x times x, x squared, x times 5 is 5x, 5x plus 4x gives you the 9x, 4 times 5, sorry, gives you the 20. So when you factor that back, you get the original, okay? So we know that these two things are equivalent. What do you notice about the relationship between the factors and the original polynomial? Okay, this is foundational to what we're about to do. So what do you guys see? Okay, feel free to pause the video here and look at the factors and see if you can figure out a relationship between them. What I'm hoping you see is 4 times 5, okay, gives you 20. 4 plus 5 gives you 9. Okay, so this is kind of the question that you're asking yourself when you go to factor. You're asking this: what two things multiplied to give you this, but add to give you this? So 4 times 5 multiplies to give me 20, but when you add 4 and 5, you get the middle term, which is 9. Okay, so that's kind of the strategy that's behind all of this. So here, let's do the exact same thing. Okay, so when I have one of these quadratics, and I should point out here that I'm only using this strategy when the leading coefficient here is 1. Okay, but what I'm doing is I'm looking at the last term. All right, and I'm asking myself, what two things multiply to give me 8, but add to give me the middle guy, 6? Okay, so if I look at 8, and look at all the possible factors of 8. So 1 times 8, 2 times 4, and that's it. These are the only possibilities. What I'm looking for is two of these factors that multiply to give me 8, yes, and add to give me 6. So notice 1 and 8 will never give me a 6, so we're not going to use this. But 2 and 4, when you add those together, they do give me 6. Okay, so I can rewrite this as x plus 4, x plus 2. And to check myself, I am just going to FOIL it back out. So x times x gives me the x squared. X times 2 gives me 2x. 4 times x gives me 4x. And 4 times 2 gives me 8. So you can kind of see why this rule works when you check yourself there. 2 plus 4 gives you the 6, and then the 8 is here, okay? So this is kind of the strategy behind factoring. So with factoring, here's something that I always tell students. The first thing you always do in your factor is you ask yourself, is there anything I could take out of all the pieces? Okay, so if we look at this thing again, x squared plus 6x plus 8. First question you always ask yourself when factoring, is there anything I can take out of all three? Is there anything in common with all three? And the answer to that is no. The only thing that's in common is 1. Next, we use this strategy that I just taught you guys. Okay, so what I'm looking for is, if I have 3 terms, what I'm looking to do is I'm looking to find 2 things that multiply to give me the last term, but add to give me the middle. Okay, so that's how I got my factors. Okay, so the rule, again, you can write this rule in your own words. I've told it to you a couple times in my own words. It's also stated on page 503, and I don't know if that's correct in your textbook. Hold on, let's fix that. We are actually on page 531. So if you want to look up the official wording of how to factor and what the rule is on page 531 under the key concept. But let's keep cruising, okay? So here is the strategy. Step 1, we write things in standard form, which means we put things in order of degree. So typically it's going to be some kind of an x squared term plus or minus some x term plus or minus some constant term, which is just a number. Okay, step 2, we're going to make a chart. Okay, you don't have to do this, but it is a good idea when you're first starting to learn this. The chart should give you factors of the last term and then sums of the 2 factors to figure out the middle guy. Okay, so what that looks like is this chart actually refers to what we're doing here. If I have 20, the factors of 20 are 1 and 20, because 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. Okay, so these are all possibilities. Right, what I'm looking for in this case, since the middle term is 9, is I'm looking for 2 of these things to add up to 9. So 1 and 20, if you add those or subtract them in any way, you're not going to get 9. 2 and 10, the difference of those 2 things is 8. If you add them together, you get 12, so that doesn't work. Okay, so then we go to 4 and 5. 4 plus 5 does give me 9, so these are the 2 that work. Okay, so when I go to factor this thing, I'm simply going to rewrite this as x plus 4, x plus 5, because positive 4 and positive 5, these 2 things add to give me 9 and multiply to give me 20. And again, the reason we're doing that, you guys, because I know some of you guys are probably confused, like, why are we doing this? Well, there's a couple of reasons why we factor. One of them is we want to know where the zeros are so we can figure out a good picture of this thing. But as to why we're choosing the 4 and the 5 here, it's because when you FOIL this back, it kind of explains it to you. X times x gives me x squared. X times 5 gives me 5x. Okay, so if I FOIL this out, I would have x squared plus 5x plus 4 times x, which is 4x, and then 4 times 5, which is 20. Okay, so when I FOIL it back out, I get my original back. And that's so crucial here. When we factor something, you guys, this thing should always, always, always equal the original. It's just another way of writing it. Okay, so it's kind of undoing this problem to figure out its simplest pieces. That's what factoring is all about. Okay, so those are some strategies to do that. So let's do some examples now. Let's move into example 1. Okay, so I know that I gave you all this stuff. Let's kind of ignore it for a second. If you just had this on your homework, strategy is this. Number 1, can you take anything out of all 3 pieces? The answer is no. Number 2, I am looking to see how many pieces I have. I have 3 terms here. Okay, so since I have 3 terms, I'm going to factor using the method that I just taught you. Okay, so what that looks like is I'm going to look at my last term, 24. And then I'm going to look for all the possible factors of 24. Okay, so I can start with 1. 1 times 24 gives me 24. 2 times 12 gives me 24. 3 times 8 gives me 24. 4 times 6 gives me 24, and I believe that's all of them. Okay, in this case, we are looking for two things that add to give me 11. Okay, because 11 is my middle term. So if I were to add or subtract, 1 and 24, there's no way to get 11, so that doesn't work. 2 and 12 doesn't work either. But 3 and 8, 3 plus 8 is 11, so that is going to be the one that works. So what I'm going to do is I'm going to just rewrite this thing as, not x in this case, but it would be d plus 3 and d plus 8. Okay, those are the two possibilities, and if you FOIL this back out, okay, if you multiply that back out, you should get this the original problem back. All right, so that's 1A, and I encourage you to do 1B on your own before I do it here, but I'm going to just cruise right into it. The first thing I'm going to do here is I'm going to write this in standard form. Okay, so it's not in standard form. I'm going to put it in standard form. There we go. Once it's in standard form, I'm going to do the exact same thing I've been doing. So I'm going to look at the last term, 9. Okay, what are some possible factors of 9? We have 1 and 9. 2 does not go into 9, but 3 does. 3 and 3, and that's it, right? Okay, so we're looking for a pair of factors that add to give me 10, because 10 is the middle term. The only ones that add to give me 10 are these guys. So what this thing is going to factor to is t plus 1 and t plus 9. If you were filling in the chart, you would have factors of 10. This would be 1 and 9 and 3 and 3. If you add these, you get 10. If you add these, you get 6. So we're going to use this one. Okay, the answer I have already given to you right here. Okay, so that is the factored form of this original problem right here. Okay, so that's 1B. Now, once in a while, you guys, we will have quadratics where we have different signs. So all of them up until this point have all been positive. Now we are on ones where we have a negative. Okay, so what's interesting when you have a negative is in order to multiply to give you a positive term, two things that multiply to give you a positive but add to give you a negative, these will always be two negative factors, okay? And you don't really have to memorize this rule because it'll come out when you guys are figuring this out. But it is kind of important to remember that if you have a positive term at the end and a negative term in the middle, you're going to have two negative factors. Okay, so let's look at what this looks like. So for 12, we're going to look at the factors of 12. Okay, so what things multiply to give you 12? Okay, I said negative factors of 12 here, but let's just look at the positive, okay, for now, and then we'll relate it to what I'm saying over there. So 1 and 12 is a pair of factors, 2 and 6, 3 and 4, and I believe that's it. Okay, so we're looking for two things that give me a possibility of 8, okay, because 8 is the middle. But 8 is negative. Okay, so 2 and 6 give me 8, right? But they would both have to be negative, because negative 2 times negative 6 gives me 12, but negative 2 plus negative 6 gives me the negative 8. Okay, so when I go to factor that, I get x minus 2, x minus 6. By the way, there's another video out there, factoring quadratics with leading coefficient of 1 on Khan Academy. I have it here. I'll try to link this to the site so that you guys have it. But if you want to see another explanation of what I'm talking about here, it is out there. Okay, what if the third term is negative? Okay, so if I have something like x squared plus 2x minus 3 or something like that. If this term here is negative, the factors are going to have opposite signs. Okay, so one will be positive, one will be negative. The reason for that is, well, we know a negative times a negative equals a positive, and a positive times a positive equals a positive. So the only way to get a negative when I'm multiplying two things together is if I have a positive times a negative. Okay, so they'll have opposite signs. So let's look at some of these. So for this one, we have negative 15. So I'm asking myself, what two things multiply to give me 15, add to give me 2? Okay, so let's look at the factors. 1 and 15 can never get something that's equal to 2, so that's not going to work. Let's go to 3 and 5. Okay, so 3 and 5, this could work, okay, because the difference between 3 and 5 is 2. So what we got to think about is which one's positive, which one's negative. Okay, so 3 times 5 gives me positive 15. But if I'm looking to get a positive 2 as my middle term, what I'm going to need is a negative 3 and a positive 5. Negative 3 plus 5 gives me 2, but negative 3 times positive 5 gives me the negative 15. Okay, so that's how that works. So this would become x minus 3, x plus 5. All right, and I'm putting that out down here. And then another example here, this guy, this one's negative, and this one's negative. So that one's kind of interesting. So here we go. We're looking at negative 18. The factors of 18 would be 1 and 18, 2 and 9, 3 and 6. Okay, we're looking for a possibility of a negative 7. These guys definitely have a difference of 7. Okay, so 2 and 9, if you subtract them, you get 7. So we're looking at that. Now, if you multiply, or if you add, I should say, a negative 9 to a positive 2, you get that negative 7. Okay, so what I want to do is I want to factor this thing using these two pieces, x plus 2, x minus 9. Again, the reason for that is 2 times negative 9 gives me negative 18. 2 plus negative 9 gives me negative 7. So that is why I chose positive 2, negative 9. It's the only factors that will work. All right. Let's cruise right along into example. Well, let's do this one, I guess. So the factors of 48, if we look at the factors of 48, we have 1 and 48. We have 2 and 24. We have 3 and 16. 4 goes in 12 times. 6 goes in 8 times. Is there any more here? Well, let's see if one of those works. If one of these does not work, we'll keep going. But I think I see one that's going to work here. I need a 13 as my middle term, and I see that I can get a 13 here. 16 minus 3 is 13. Okay, so this one's going to work. If I sum the factors of these things, negative 3 plus 16 gives me 13. Okay, so that's why I chose the negative 3 there. So my factors of this thing would be y minus 3 and y plus 16. And sure enough, if I FOIL this back, y times y gives me y squared, y times 16 gives me plus 16y, negative 3 times y gives me negative 3y, and negative 3 times 16 gives me negative 48. Okay, so if I combine like terms, I get this guy, and I am good to go. I get the original term back. So this is my factored version. Okay, I think what I'm going to do, there's so much more here to learn, but I don't want this video to go on too long. I'm going to do one more with you guys, and then I'm going to kind of let you guys play with this idea. Okay, so for this guy, we have 3 terms. Nothing can be taken out of all 3, so we're going to move to our factoring method. The factoring method is this. We're looking at our last term, which is negative 24. We want 2 things that multiply to give me negative 24, but add to give me negative 2. That's what I'm looking for. Okay, so negative 24, I always just look at the positives and then worry about signs later. So 1 and 24, one of them's going to be negative, but that's okay. 2 and 12, 3 and 8, 4 and 6. These are all factors of 24. We can keep going, but we'll end up getting 6 and 4, which is the same thing, and then it just starts over again. So we're just going to stop there. Okay, I'm looking for a difference or a sum of 2. This one will definitely not give me a difference or a sum of 2 or negative 2. This one will not either. Neither will this one, but this one will. Okay? If I have a negative 6 and a positive 4, negative 6 plus 4 gives me negative 2. Okay? So that's what I'm looking for. My two factors are going to be r plus 4 and r minus 6. Again, you can FOIL those out and you should get the original term back. Okay, so this is just the beginning of factoring, you guys. Again, this is a super crucial skill, one that you should not take lightly and you should definitely practice very well in your homework. I'm going to wrap this video up. Maybe I'll do another video for the last two examples, or maybe I'll just teach them on Zoom. But hopefully this gives you a jump start for the lesson. All right, thanks guys.